still a little longer video. Let's turn my volume down with my rudimentary screwdriver. So what we have here is a TDA 2030 audio amplifier, and then for the actual radio we have a single 2n2222 with bias resistors. One of them goes to ground, the other two to your voltage. And then I'm using on the underside of this board a 43 ohm gate stopper resistor, and I'm sensing the tank through a 47 picofarad capacitor to the base of the transistor. I have a 470 picofarad bypass capacitor, because I was having some trouble with loop gain and keeping it controlled. Then off of the collector we have our audio through a capacitor that I don't remember the value. And what we're doing is we are link coupling to the toroid, and we've got a twisted pair running all the way up under the board, coming back up to this copper formation that I have made. If you think that's a stray capacitance nightmare, you would be correct. Our tank circuit is, I don't know, I didn't measure it, I just wrapped some coil around and made it look how I wanted it to. Ended up about 2 microhenries, and this is a 20 picofarad through a 1000 picofarad capacitor. Right now it's bypassed, but I have a series resistor to bring the tuning range in. A coupling capacitor for the antenna wire. That of course depends on the wire in question. And I tried all the emitter degeneration tricks by using a rheostat to ground. I couldn't get that to work. Tried using a rheostat on the tickler winding. I couldn't get that to work. Tried a voltage divider on the tickler winding. Couldn't get that to work. So my regeneration control ended up being a voltage divider to the entire feed circuit. That way I don't have any phases fighting each other and all that kind of stuff, because it's the most linear control. So what we have now is, of course, we're here in a station, CW, WWV's in the background. But we have our little potentiometer here. If I turn her up, then we go into full BFO. And we could see it on our little spectrum analyzer there. As we tune through, you can watch it, see the range. See, it phase locks on the frequency, and then we can back down our voltage and then get lighter regeneration. And we can turn up the audio, and there you go. Now we're locked on one station. But that's the basics of how this wide layout and straight capacitance and non-mathematical formulas worked out to be a functional single transistor regenerative receiver. Definitely would do it a little different, but this is the first one I've ever done, so we did our best. Good luck, and I'd love to see if any of you try to build it. But one transistor, minus the audio amplifier. But the actual detector and all, that's one transistor. Good luck, 73K5 UCL.